Higher level, paper 2, question 13. Let's go to a calculator page and let's just define the variables that we're given. So mu is equal to the 1 plus the square root of 3 times I. We're not doing the first part of this question because even in Inspire I can't do proof by induction. V is defined as being 1 subtract off I. Oops. Let's go to there. Okay, so be asked to write it in modulus argument form. For each of these complex numbers you can get that quite quickly. For the modulus you can go to the template, choose the modulus template and just simply type in mu, and there we go. Alternatively, you can do menu, number, go to the complex number tools, and you can go for the magnitude, and it gives you exactly the same command there. You may have noticed there were other things we could have used there, so menu, number, complex number tools, and if I go for the polar angle of u would be that value there. You may not recognize it, but if you divide it by pi and press enter, you get a third. So pi by 3 would be the polar angle of mu. And we can repeat the whole process for v in a similar fashion. Moving on, it then wants us to work out u cubed and times v to the power of 4. We can just simply type that in, u cubed multiplied times v to the power of 4, and we get an answer that looks not quite like 32, but if you look very carefully it's looking for such a small imaginary part we may as well call it 0, and so therefore it must be the number 32, and that will have just come from rounding errors. Now we're going to move on to part C and plot these things on an Argand diagram. The quickest way to do that is we're going to insert a page of lists and spreadsheet, and we're going to create a couple of lists for the real components and the imaginary components, and we'll just type in the information we were given. So 1, and we'll have the square root of 3 in there, and we'll continue to 1 and we'll have negative 1 there, and we're going to plot a scatter plot of these. Now what we could do is just check that everything's fine by quickly going to a data and statistics page, and if I plot the reals along the bottom and the imaginaries up the side, there's my Argand diagram with the 2 points plotted, but the scales aren't great here, and so I'm just not going to use that page at all. I'm going to go straight ahead to a graphs page. I'm going to press menu, do graph entry edit and go to scatter plot, and I'm going to look at my real numbers and my imaginary numbers, and I've got the 2 points plotted there. Top one is u and the lower one is v. If I just rescale the axes, it will make it just a little bit bigger. And what I'm going to do is I'm going to be doing some rotational geometry here, so I'm just going to check what the settings are. So I'll press menu, settings, and I've got them both in degrees. Now I know that Argand diagrams are normally in radians, but I'm just going to cheat a little bit and keep everything in degrees here. And I'm going to rotate this point by 90 degrees all the way around. So what I'll do is I'll do menu, geometry, transformation, and then a rotation. And it's looking for the rotation point by the icon first of all, so I'll click on there, going for the actual point itself, and if I type in the number 90, this point over here that's just turned up is a rotation of 90 degrees in the anti-clockwise direction, like that. Similarly, we're going to do a clockwise direction of this point here, so I'm going to click on the center, I'm going to click on the point in question, but now I'm going to type in negative 90, but I have to type a number first to get the entry up, and then I can edit it as negative 90, and that point has been rotated around by an angle of 90 there. So we're looking for the triangle OA prime B prime, so it's going to be the triangle over on the left, so I'm just going to press escape so I don't do any more rotations here. I'll do menu, geometry, shapes, and I'll look at the triangle, and it's going to be the triangle from that point to that point to that point, and fix it. I'll press escape to get out of triangle drawing mode, and when I go over the triangle and press control menu I can measure its area, and its area works out to be 1.37 square units, so that should check with any answer you may have got by more precise algebraic techniques. And for the last part, for part E, the ways in which you might go about it, there are many and varied, but whenever you get an answer you could be able to check it. If I just press Control Doc to insert a new page, if I've already worked this through and got what I think to be the coefficients of B, C, D and ER, and so I can go to Menu, Algebra, Polynomial Tools, and the roots of the polynomial. The polynomial we've been given is a power of 4, we're after complex roots, and if we click to OK, and so the coefficients of the power 4 term is 1. I think the next coefficient is -4, then it goes 10, then it goes -12, and then it goes 8. And that'll construct the C polyroots command for me, and when I press enter, it'll pop up numbers which are recognizable. You may recognize V there, and then the complex conjugate of V, and then you've got U there, and the complex conjugate of U. So we have all the points on show, and it's all checked out. We're done.